Hello class. This is a review packet, review 3. So describe, problem number 1, describe the definition, not the domain of the F. So you have this one. The domain is where the inside is non-zero, no, is positive or equal to 0. What does it mean? Mean when you have x, 4 minus x squared is greater or equal to 0, and then you have x squared is less or equal to 4. So if you take the square root both sides, that's why this one is absolute value of x, which is less or equal to 2. That's why I have this one. From here, I will have this one. Okay, so you have to know it. I just skip this one because I think you know it already. It's true, but it's where I get absolute value of x is less or equal to 2. But I want you to show your work like this. And then from here you can get, let me erase this one. And then from here you can get the denominator has to be non-zero, which is always true, by the way. Why? Because you can't not found a y such that y squared plus 3 is equal to 0. You can't. Any y you will pick, y squared plus 3 have to be non-zero. Have to be non-zero, okay? And then y squared plus 3 it cannot be equal to 0. Then the domain is all x and y because it's a pair. All x and y such that x has to be belong to -2 and 2. Okay? And then y have to be all real numbers. It doesn't matter. That's the domain you have to find. Okay, the second one, it said to describe the domain of f, and you have the f like this. So then the denominator have to be non-zero. What does it mean? Mean x plus y plus z have to be non-zero. And you know something. You know this one, it represents to the is the plane. Is equation of the plane. X plus y plus z equal to 0. That one is equation of the plane. But since this one have to be non-zero, and the domain is all x and y and z such that this one, x plus y plus z is non-zero, and x plus y plus z equal to 0 is an equation of the plane passed through the origin. Why? Because x minus 0 plus y minus 0 plus z minus 0 is equal to 0, and you can tell the origin is 0, 0, 0. Okay, the next, problem number 2. It says describe the level of the function such that the contour map of the surface using the level of the whatever. So you have 8. 8 is x squared plus 4y squared is, and c is given. Now, if c equals 0, what does it mean? Means z have to be equal to 0, right? And then you have to find the function. So now you have this one, and then you end up having x squared plus y plus 4y squared equal to 0. So what does it mean? Mean you will have x squared plus y over 1 over 2 square. Be careful here. And you have here square. And that one is what? This one is ellipse. Okay, it's ellipse. And you have here 1/2. So what does it mean now? Let me just use the red one. Okay, you have x squared plus y over 1/2 square equal to 0. This is ellipse. So now if you take 1 over 4 and you flip it, that's why you have 4 here. Okay? So now this one is ellipse. It's elliptic at the origin 0, 0. So what does it mean? What does it mean here? Mean here c equal to 0 mean you have only 1 point. It's only one single point. Okay? The next one, if c equal to 1, you have this one. Just like I told you right now about the flipping 4 is this one. So if you flip it again, you have x squared plus y squared over 1 over 2 square. Okay? What does it mean? Mean on the x-axis you have 1, and on the y-axis you have 1/2. And you can tell it will be like this because x is greater. This is elliptic equation, okay? No, elliptic equation, yes. Elliptic form. You can tell on the x-axis is larger than the y-axis. Because on the x-axis you can tell you have 1, and the y-axis you have 1/2. Okay? Good. The next one, same thing. If c equal to 2, now here, let me point out something. If you have x squared plus 4y squared equal to 2, you have to make sure to have here 1 always to make it in elliptic form. So if you divide both sides by 2 plus 4y squared over 2 and then equal to 1. Now you have elliptic. And now you have to change a little bit. So here you have x squared over, 2 is square root over 2 everything square. And this one is a square root over 2 everything square. Okay? And then here you have 2y squared, which is y squared over 1/2. And square root of 1/2 everything square equal to 1. So now you have elliptic form, elliptic equation. So here on the x-axis you have a square root of 2. And you know what? A square root of 2 is just 1.7, 1.4, I think so. And this one on the y-axis you have 1 over square root of 2, which is smaller. And then you can have the same thing, elliptic, just like this. The first one was a point, and the second one was like this. That's why I have this one. And if you keep going, you will have like this, x and y. Okay, that's it. That was a problem number 2. Let's do now problem number 3. Let me erase here. Okay, problem number 3. Oh no, B. For the B, you have the same thing. You have c equal to square. Okay, and then you end up having x squared plus y squared equal to 9 minus a c squared. So now you have, if c equal to 0, so you have this one. Now, what's this one? This one is a circle center of 0, 0 with a radius of 2. No, or with a radius of 3. Same thing here, you end up having, if c equal to 1, you end up having, the radius is 2 square root of 2. Why? Because 8 is 2 square root of 2 everything square. Why? Because this one is 4 times 2, which is 8. Okay? So now you have this one, and then is a circle center of 0, 0 with a radius of 2 square root of 2. And do the same thing also if c equal to 2, same thing. And then you end up having circle, the smaller, because here the radius is 3, and the next one is 2 square root of 2, and the next one is square root of 7. And you can tell it getting, sometimes it getting bigger, sometimes it getting smaller. And you can, in our case here, it getting bigger, okay? And then we end up having this one. So now the next one is z equal to 6 minus 2x minus 3y. Here you will have, if you move the 2x minus 3y outside, you end up having this one. And the next one, you end up having, you express y in term of x. If you express y in term of x, you end up having that equation. If you express y in term of x, you end up having that equation. Same thing here, c equal to 2, you end up having that equation. Same thing here, you end up having the equation. So what's our, we have a slope, and that slope is negative 2 over 3. 2 over 3. That's our slope. The only difference will change is when you have, when x equals 0, you have the y-intercept. The y-intercept here is 1/2, and here is 4 over 3, 2 over 3. And you can have a strict line, okay? It's like this. Okay, that's all I need. You want you to show. But before that, I want you to show your work like this. Okay, good. The next one is when you have fx equal to e to the ex over 2, and then you can keep going, do the same thing, and you take c equal to a constant. Some of you may use e equal to ec. It's fine, but you have to be very careful. But this one is the best way, so you can just set c as a constant equal to 2, and then you keep going. You keep going. You end up having here our first function we express in terms of x, y in terms of x, we have this one. We have the equation, and we have the equation, and we can draw it. Why? Because if you, okay, from here to here, be careful here. Because from here to here, okay, this one from here to here, you have the graph will look like this, okay? Like this, no, like this, sorry, like this. But from here to here, the graph will be the opposite, like this, okay? That's why the general graph will be like this. Good. The next one, problem number 3. Very quick, problem number 3, you have found the limit and discuss the continuity of the function at point 0, 1. So here, along the line, y equal to 0, for example. So we have a limit when x and y goes to 0 and 1, because it's a given limit. So that's the limit we have to find. If you keep going, you have arc sine of 0 equal to no over 1 minus 0. It's just arc sine of 0 over 0. So here you have 0 over 1, which is 0, of course. Okay? Why? Because sine, for example, is sine something equal to 0. So which one should be? You can have a pi, you can have 0. Okay? You can have a pi, you can have 0. It doesn't matter the limit. No, it doesn't matter here. At least the limit is final. So, and then the limit does exist here. Okay? On that path. So then x1 minus xy, first of all, has to be non-zero. So the domain for this one, if you keep going, you have x minus y, it has to be non-zero. And then x minus y have to be less or equal, has to be between x, has to be -1, between -1 and 1. Now the problem here is here. If x and y is 1, then the function is non-defined. Then 1 have to be excluded on the domain. So the domain should be -1 and 1 excluded. Or you can write down -1 less equal to 1 into x, and then less equal to xy, and less equal to 1. You can write down like this if you want. So you keep going. That's the definition for the limit. And then you can tell from 0 and 1, replace it here. You have y equal to 1 and x equal to 0. That one exists. Why? Because you have x01. Let me show you x01. You have the top, you have arc 0, which is 0 divided by 1 minus 0, because x and y is 0. And then you end up having 0 over 1, which is 0, which is exist. That one exists. And the limit of this one also exists. Then the function is continue. You got it? Good. I didn't write it down, but okay. Remember the function, the limit. Okay, just get the limit of the function. Then the limit from here, I didn't write down, but the limit, the f is continue, okay? F is continue at 0 and 1. Good. The next one, you have this one. Now, if you check the limit at point 0 and 1, for this one, x is 0 and y is 1, you end up having arccos is 0 over, it's just 0, okay? Now, if arc 0 of 1 is 0, so it's just pi over 2, and divide here by 1, and you have pi over 2, okay? You can have also you can have pi over 2, you can have 3 pi over 2, extra. You keep going. Okay? And then here the limit is like this. Now along the path k, let's choose a path which is x is equal to let me erase here. Let me choose a path such that x is ky. Okay? If you choose a path, you have a limit of x and y goes to 0 and 1 is equal to y goes to 1, such that the limit is this one. Make sure here is x and y, and you, yeah, because here if x is ky, then x over y is just k, because the y will cancel out. That's why you have k here. And then you have this one. Now if y goes to 1, you have this one. That's the limit. Now you have to put it in cases. If k equals 0, you end up having this one, pi over 2. Okay? And then here if k equals 1, you have 0. Why? Because if k equals 1, look at here. You can have ky equal 1. What the y should be, then y can be pi over 2. If you have cos of arc, let me clarify something here. If here the way I wrote this one here, let me just clarify here. You have arc. I know you know, but just to remind you, arc of cos of 1 equal a z. That's the way you have to do it, just for example. So you will have cos of z is equal to 1. What kind of z we should have such that this one is true? Okay, that's the way you have to think. What kind of z we should have such that this one is true? We can have a z equal to 0. We can have also, yes, z equals 0 is the best way, and then we end up having this one. Got it? And then from here you can tell, since this one and this one are different, okay, since pi over 2 and pi over 2 is different to pi to 0, then this one does not exist. Okay? Do the same thing here and same thing here. Okay? Same tactic here and same tactic here. Take the path for this one and you end up having m equal to 0. From here, m equal to 0, you have this one, and m equal to 1, you have this one. They are different, then f is not continue. Same thing here. Here is different because here you have 3 variables. Here you have to choose x equal to ay and z equal to ay. And then replace it here. You end up having only a function in terms of y, and then it's this one. So now you have to choose if 8 equal to 0 and 8 equal to 1. If 8 equal to 0, you have the limit of this one. It will goes to 0, and this one is go to 1. Since they are different, then the limit does not exist. And then the function is, yes, the limit does not exist. That's it. The limit does not exist. And do the same thing here. And they ask you to find the limit. Be careful here. If they ask you to find the limit, if the denominator is a radical, so you have to find the conjugate. Okay? Find the conjugate and you have this one. And x minus y minus 1 will cancel out, and you end up having this one. And you take the limit when x and y goes to 2 and 1, and you replace it here. You have 1 plus 1 equal to 2. That's the limit. Okay? Let me stop here, and I will do question number, problem number 5.